I'll stand. It's a little more engaging. Hey, everyone. Can you hear me okay? Thank you guys for coming out. This turnout's amazing. This is my first time in Prague, so thank you so much for all of your hospitality and coming to say hello. And I'm really looking forward to talking to you guys and seeing all the cool stuff you're working on. So my name is Tom Dale, if you missed it. Yehud and I started a company together, and we also work on several different open source projects. Okay, I will not walk in front of the screen. My apologies. I have a habit of pacing when I'm on stage because I'm nervous. So the thing I'm here to talk to you about today is Ember, but more specifically, Ember-data. How do I click? Oh, screw this. All right. Boom, Ember-data. So I imagine I see a lot of AngularJS t-shirts and stickers around. So I talked to Igor. I told him I was coming to give a talk to a hostile crowd. So please save your jeers and thrown tomatoes and other rotten vegetables until after the talk, and then you can throw them at me as much as you want. Yeah, I told Igor I was coming at him on his home turf. Okay, so why am I here? I'm here to talk to you about Ember-data. And Ember-data is basically a library for getting data from the server, getting records, and then persisting them back. So the reason we wrote this library is there's a problem. It's a big problem. It's a problem that basically everyone writing a web application faces. And that problem is this. You have some files. They're in the cloud on your server, and you really need them in your web application because your web application doesn't do much without data. So the question is, how do you get the data from here over here to the web browser where your user can actually see it and manipulate it and do cool things with it? Now, if you're like a lot of people and you're faced with this problem, you think, I know. I have an idea. I know how to solve this problem. You think, I will use something like Backbone and the Backbone sync method, and this will solve all of my problems. No. No, this won't solve your problems. This will create problems. Well, I'm not here just to talk smack. I want to tell you why we think that we need a better solution and why we think what we're doing is cool, and basically all the things that you would want, all the things that you should look for when you're figuring out what you're going to do to communicate changes, get records off your server and communicate those changes back. So I'm not saying that you should use Ember or that you should use Ember-data, although it would make me happy if you did. I'm simply going to say, here are the things that we think are important, and hopefully you'll think about those when you're choosing a solution. Okay. So here, I thought about it a lot, and when I say a lot, I mean for about half an hour in my hotel room last night. And these are the things I think that are important in Ember-data that I think will be important to you. These are basically all the things that we couldn't find in other solutions, and we tried really hard. We didn't really particularly want to write Ember-data, but nothing we found we felt had all of these things, and we think these are key. So what are they? So number one is simplicity. I'm going to go deeper into each of these in turn, so don't worry if I don't cover these right away. So simplicity. You basically want an API that is understandable. You can read it, and when other engineers come in and look at the code that you wrote, they can see what's going on. And also, each of the objects in the system should have specific roles. So you should never wonder, like, should I put this piece of code here, or should I put this piece of code there? Everything should have very well-defined roles. The second thing that we thought was extremely important and actually blew our mind, was not really in any of these solutions, is relationships. So if you've ever used a relational database or you've ever written a web app, like PHP, Rails, Django, whatever, you're creating models, and those models, by definition, have relationships between them. And yet, every solution that we looked at in the JavaScript world either didn't support relationships at all. You basically had to hand code the relationships by looking at the JSON structure that was returned back, or the support they had for it was extremely rudimentary, to the point where it seemed like it wasn't actually particularly useful at all. So relationships. The next thing is an identity map, and I'll go into this in a bit more detail, but the premise behind an identity map is basically every time you ask for a record with a given ID, your data store, whatever it is, should always return the same object with the same ID. And this is important for a couple of reasons I'll enumerate. The fourth thing is what I call here malleable backend semantics. And what I mean by that is I'm sure that you guys are doing really cool stuff with your backends. You're making crazy APIs. You're doing stuff that maybe doesn't seem good at first, but you're doing it for performance reasons to minimize the number of HTTP requests. You're using a lot of really exciting new backend technologies, right? So it's not just Ruby on Rails on top of MySQL. In fact, you're doing all sorts of like streaming, WebSockets, MongoDB, React, whatever crazy Hacker News link bait title you've got for the day. And we want to be able to support that. We don't think that, most of the things that we looked at would just hard code RESTful Rails-like semantics. And that's fine if you're on Rails, but we basically want to give tools to allow you to plug into all these different backends and not have to change your application code. And finally, maybe this is obvious, but lazy materialization is extremely important, right? So if your user logs in, and let's say you're writing an email client, if they have 100,000 emails, you clearly don't want to load megabytes and megabytes of JSON before the app boots. You would like to load as little data as possible while still loading enough that you're minimizing the number of HTTP requests. And so how do you find a way to balance that and do it in a way where the asynchrony of loading in this data doesn't make your application a bunch of callback spaghetti? Okay. So let's talk about specifically simplicity. What I mean when I say simplicity is you really don't want to expose more concepts than are absolutely necessary. So here's a good example of this. Basically, every persistence library that we looked at exposed the concept of something called client IDs. And a client ID is basically the fact that you have a record, you've created it or you've requested it, but you don't actually know the server ID yet. So your persistence layer creates something called a client ID, which is a temporary thing that it can use to refer to internally. But this is basically a side effect of the bookmarking that your tool is using. So Yehuda and I decided very early on we wanted to try to create an API that, if at all possible, didn't leak out this internal bookkeeping that we needed to do to your application semantics. And in fact, we succeeded, which I think is cool. So if you're using Ember-data, if you're writing an adapter to make Ember-data work with your backend, you never even have to think about what a client ID is. And we think this is actually a huge priority for us. We don't want to have to leak abstractions or concepts because your job is already hard enough. And we want to help insulate you from anything that you would otherwise not have to worry about. So again, as I mentioned before, a readable API is obviously nice. We want something that would kind of feel at home in like a jQuery app, but would allow you to really marshal data in a way that it was obvious what was going on, and there weren't. Basically, to remove all the cruft, JavaScript can be a very noisy language. How do you create an API that minimizes that to as little as possible? And finally, when we say simplicity for the architecture, we really want something that encapsulates the asynchrony and network code away from the app code, right? So you can think of your app code as like a town. Now, if everyone... I have no idea where I'm going with this analogy, by the way. I literally just came up with it. So you can imagine that there is pollution going on down at the factory, and it's leaking into the river. And the river is flowing down, and you're going to get the tap water, and you try to drink it, and it's disgusting. It has all these pollutants in it, and your kids are growing like third arms, and everyone has cancer, and it's just like, this is terrible. So you really have two options. You need to clean up the pollution. Now, you can clean up the pollution where it's happening at the factory, and then everyone can come to the water at any point, and they can get it, and they can drink it, and be happy, and their children can live for many, many years. Or instead, they can each take out the tap, get their filter it at the place, and basically now everyone is dealing with the pollution. So we think instead the experts should deal with the pollution, and that way no one else on, this would now be the engineering team, to take the analogy back to real world, no one on your engineering team actually has to deal with the pollution. You send in the experts, they create nice abstractions around this asynchrony, and everyone else can go on with their happy lives, and everything is good. How is that analogy? Good? Yeah? No? Oh, boo, I'm being booed off. Oh, bummer. Okay. Well, anyway, that's the point. You can encapsulate the asynchrony, and you can write nice apps, and you can basically keep all the craziness in one spot. All right, relationships. So obviously, objects in real life, as in our data models, have relationships with one another. One object might have many other things. One thing might belong to another thing. You should be able to see that information when you get it from the client. So if you request a record, you should be able to see the other records that it's related to. And maybe not even materialize those records, right? So this is the important thing. It relates to lazy materialization. You want to be able to say, I have a child object, I want to get its parent, and if I haven't loaded that, please go load it for me asynchronously and basically give me something I can use right now. And importantly, in addition to being able to see those relationships, you should also be able to change those relationships on the client. The order shouldn't matter. You should be able to make a bunch of changes, save them up, and then send them down the pipe. And so this is related to app code doesn't care about creation order. Basically, you can create objects. It doesn't matter if they haven't been saved to the server yet. Create 1,000 if you want. Who cares? Put them all together, save them. Everything should work, and you shouldn't be responsible for creating the dependency tree of what has what ID when. So identity map. So again, an identity map basically means every request for a record always returns the same object, assuming it has the same ID. And this is important for two reasons. The first is, especially when we're building these quite complicated and quite sophisticated client-side applications, you have long-running state, and oftentimes the user will be viewing the same object in multiple places. And what that means is if you make changes to one particular record, you want to make sure that those changes are synchronized across the application, and you're not responsible for doing that manually. And the second, more obvious benefit is that if the store already knows what objects it has loaded and has returned to you, you avoid redundant HTTP requests. You're only requesting data that you haven't seen before and not making more requests than you need to. Okay, malleable backend semantics. Don't hardcode REST. Every other framework we looked at that has these kind of persistence, for the most part, was hard coding the assumption that you have a one-to-one mapping between an endpoint and a resource, and basically, if it didn't match, they're like, okay, sorry, we don't really fit your needs. Here is a single method, do what you will, and that's just crazy because now you have to do a ton of work. It's 2012. This is a problem that everyone has. Not everyone should be writing this code over and over. So again, be flexible enough to support any backend. Key value stores, document stores, relational databases, local storage, whatever. We don't care. And this is important because backend changes don't change the app code. You basically isolate the part of your app that changes the model layer into your over-the-wire protocol, and everything else stays the same. Now, a lot of people are like, okay, that's fine, but there's not actually a lot of benefit. It doesn't seem likely. We have a pretty established app. It seems very unlikely that we will end up swapping out what our backend is. And my answer to that is, even if you never will swap out the backend, it seems like a sign of good architecture if you can, right? So even if you don't ever plan on swapping out the backend, maybe you will, but if you don't, this is at least a sign that you have good encapsulation and good architecture. And finally, so it turns out that building this is incredibly hard, and this is basically what we've been banging our heads against the wall for the past few months. This is really hard. And there were definitely points of despair in the project where we're like, maybe this is just too hard and maybe we should give up. But the reason that we powered through the misery is because of local storage, right? My personal belief is that within a year or two, if you are writing a web application and you don't have offline support, you're basically going to be a joke and everyone's going to laugh at you. So so even if you don't have a key value store on your back end, guess what? IndexedDB in the browser is a key value store. So you better be damn sure that you can write to it. And we think that if we pull out semantics that are sufficiently high level, and then we can write an adapter layer that can write to either relational database or IndexedDB, turning your local IndexedDB into a write-through cache is going to become not easy, but at least achievable. And finally, and I think this is the most obvious of the five, so lazy materialization, avoid doing as much work until as late as possible. Obviously, we still have users who have limited CPU, who maybe don't have the fastest browsers. So make sure we only do what we need to do at the latest possible moment, and that allows us to amortize this work over the runtime of our application to the point that hopefully our users won't notice what's going on. And this allows us to stream in the data as it becomes available. You can imagine opening a WebSocket and having information stream in. And this doesn't really have to do anything with lazy materialization, but this is the last slide, so not of the whole presentation, but of this section, so I stuck it in here. Aggressively cache. So I was me and Yehuda were trying to find a place to hack because the Wi-Fi in our hotel wasn't working. So we went to the Palladium and went to Cafe Costa Coffee, and their Wi-Fi was like 0.5 megabit per second. It was really miserable. And in fact, the only applications that were pleasant to use were, I was using Tweetbot to check Twitter, I was using Adium to IM with some people, and I was using an undisclosed Ember app that's in beta testing that I'm under NDA about. And these were the three things that were actually pleasant to use, because they were both aggressively caching data to the local storage as soon as they received it over the network. So if I went back to look at something that I had just looked at, it loaded immediately, and they were exchanging very small JSON payloads with the server. So I think it's easy to take for granted that everyone has really nice, fast, consistent Wi-Fi that's low latency, but in fact, this is not reality. So aggressively caching ends up being very important. Okay, so I've blabbed a lot about the ideals of what we tried to build, and I think we were pretty successful. So what I'd like to show you now is basically just what the API looks like. And this isn't going to be a very deep technical talk, so if like your second, third, maybe fourth beer is hitting in right now, that's okay. This is pretty high level. If you want to know more, please feel free to check out the documentation, or I'd be happy to go into the details with you after the talk. Okay, so setup. The first thing you need to do is create a store. The store is the thing that holds all the records that will be loaded into your application. And then the only thing you see here is the adapter. The adapter, and I'm going to go into this in a bit, is the thing that tells Ember-data how to talk to your server. Server can be any persistence mechanism, IndexedDB, WebSocket, Ajax, XHR, Pony Express, whatever. And then you define your model. Here's what the model looks like. Now, this obviously looks very familiar to the kind of model you define on the server if you were using something like Django or Rails. In fact, we actually have a gem for Ember Rails that when you generate a resource in Rails, it will build this for you, which is pretty cool. It's pretty straightforward, right? You define your attributes, you define the type, and then you define the relationships and the type of those relationships. Pretty easy. Okay, how do you find a record? Good question. Well, there's basically a mechanism. The mechanism for doing this is you take your model, you say app.person.find, and the one that I'm passing in there, the argument is the ID. So it can be a string, a number, whatever. And here's the important bit. Here's what makes this cool. So this will synchronously return an object. It will return a record object. That you can think of this record object as filling a similar role to like a promise. Like if you've done any asynchronous programming in JavaScript using promises, you can think of this like a promise. So basically it says, am I loaded? No. If I get the first name, is it there? No, it's not. But if you wait a bit and the adapter goes to the server and it's like, cool, let me go get the server, get the data. Well, when it comes back, if in just a second you say person.get is loaded, guess what? Now it's true. And if you ask for the name, it will return that value. And this works because in Ember applications, right, we use handlebars, but we've enhanced handlebars so that it's bindings aware. So basically, we take this model, we put it into our templates, and because our templates are listening for changes as they happen, we can very easily say, if this record is loaded, print the first name and last name, otherwise, show a loading spinner. And so we take that object, return from the find, we bind it to our template, and then we just don't worry about it. Because the second that data comes in, it will show something, and I don't have to write any promise code, I don't have to write any asynchronous code, I don't have to write any callbacks, I don't have to add any event listeners. I just take the object that was returned, again, it acts like a promise, put it in the template, and I'm done. And I think that's pretty cool. Now, this is the case where I have asked for a record that the store didn't know about previously. But we actually have a mechanism for loading records into the store even before you ask for them. And this is really cool. A lot of people use this to pre-populate, kind of like pre-warm the cache of the application. Oftentimes you know what records your application is going to ask for. So you can preload the stuff in, which is pretty neat. But it's very cheap. It's very cheap. So we're not actually instantiating model objects at this point. All we're doing is saying, hey, store, here is a data hash of some kind. Here is the ID. And please just hang on to it for me. And so what happens is later on, so you can see this is Tyrion Lannister. By the way, this presentation is going to make a lot more sense if you've been watching Game of Thrones or reading the books. You'll still get it, even if you haven't. Okay, so here's Tyrion Lannister. He's got an ID of 2. Okay, so what happens if we load him in? Well, what happens is when the first time you request him, you say app.person.find 2, it immediately returns the exact same object, right? The exact same object as before. However, this time if we check, you can see that it is loaded is true. And so this means that if we had a template and we put it in, it would render immediately, no waiting on the network, which is pretty cool. All right, so that's how you find records and also how you load records in ahead of time. You can see it's a very simple, straightforward, nice syntax for this API. Okay, so you might be asking, how do you change records? Well, I'm here to tell you. Okay, so let's say you are Tyrion and you are traveling with a merry band of people, but you can't reveal that you are from King's Landing and the son of a Lannister. Instead, you must take the identity of Yallo of Pentos. Well, that's easy to do too. So you can see that when we find Tyrion, the first thing we check is this flag called isDirty. And it returns false, right? IsDirty basically means, are there changes that we've made on the client that we haven't told the persistence layer about? And that's false because we have got it off the server and we haven't made any changes. All right, cool. And we can get the first name Tyrion, good. Now, you'll notice that if we change the first name to YOLO, now we check isDirty, it's true. That basically means on the client, we've said, this thing has changes that are pending that we have not yet saved. And so what we do next is we say store.commit. What store.commit says is take all the records that have pending changes, any record that is dirty, no matter how many different attributes have changed, and send it to the server. And now you'll check and see, you'll see Tyrion is still dirty. So you say, Tyrion, are you dirty? Yes, he is, because the server has not yet acknowledged that those changes have been made. But if we say Tyrion.get is saving, that's true. So this is a new flag. You see we expose this API of flags, and saving basically means, hey, chill out, don't do anything. I am still sending this to the persistence layer. So now we wait a bit, wait for the server to acknowledge. The XHR comes back. And now we can check these two flags. You can see if we check isDirty, it's false. There are no pending changes. The version that we have and the version that the server have are exactly the same. And if we check to see if it's saving, no, it's totally cool, so the user can make changes. And again, this is really nice because these are all flags that if you're using handlebars in Ember, you can use these as conditionals, right? So you can show very easily and very concisely, you can have different UI based on the states of your models. And you don't have to write any JavaScript. It's very concise, and I think that's very cool. And it's live updating. Okay, what about creating records? What about creating new records on the client? So this is easy. So create a new person, you say create record, you pass a hash of the attributes that you'd like it to have. So here we're creating Ned Stark and Robb Stark, his son. And you might be saying, well, what about relationships? How do I, if you haven't read Game of Thrones, Ned is his dad, Robb is his son. So you might be saying, well, how do I set up those relationships on the client? Because most tools don't let me do this. Well, it's really easy. Check it out. Robb is set parent Eddard. Boom. Now marks both of them as being dirty. These both need to be saved to the server because they both have changes. Hit store.commit, exact same flow. How awesome is that? All right, deleting records, pretty straightforward. Basically the same thing. Tywin.delete record, store.commit, boom, deleted. We wanted to call this delete, but of course that's a reserved word in JavaScript, so we couldn't. I'm sorry. Now you might be asking, store.commit, it seems like that will save everything that has changes, but what if I don't want to do that? What if I only want to save the things that I want to save? That's easy too. So the mechanism that we have to do this is called transactions. And to create a new transaction, you just say store.transaction. This returns a new transaction object. You can add as many records to it as you want, with the caveat that for right this second, these records can't be dirty. So basically, once you've made changes to a thing, you can't put it in an existing transaction, or you can't change the transaction that's in. We intend to change this as soon as possible. And so once you've added them to a transaction, you say transaction.commit. This will only save the records that you've manually put into that transaction. And here's another neat feature is you can imagine you have like a modal dialog. The user is editing a couple different records. Well, what if the user hits the cancel button? We have thought of that. So we have this thing called transaction.rollback. Transaction.rollback basically just throws away, discards any of the changes that you made on the client side, and returns it to the last known state that we got from the server. Awesome. Okay, so that's the basic API. You can see it's not terribly complicated, but it basically covers all your bases, hopefully. And there's a couple things I didn't cover. So if you're wondering if it does something, the answer is probably yes. If the answer is no, you should come and talk to me, and I'll see about putting it in for you. Now, you might be wondering, okay, this is cool. This sounds good. I'm sold. I want to use it. However, At my company, we have this crazy API, these insane Java developers that are like probably on drugs. Like, let's be honest, I've seen their API. They're probably snorting meth on their lunch breaks. Okay, so how do we deal with this? Well, we thought about this for a long time, and the way that you do it is something we call an adapter. So if you're familiar with something like Ruby on Rails, Rails has active record, right, which is an ORM, an object relational mapping. And that has different adapters that allow you to use active record on MySQL, Oracle, Postgres, whatever. So this is kind of where we took the inspiration from, except for the fact that there are far more crazy JSON APIs in the world than there are relational databases. It turns out that the level of entry to get into writing a crazy API is actually the barrier to entry is quite low. So there are many of them. So an adapter basically sits here, and it's the bridge between the store that you created and all the application level semantics and your server. And we split the adapter into two different objects. So you can override one or both of these and customize them. So what are the roles of these things? So adapter and serializer object. The adapter answers questions like this. If you have a parent and you have a child, so you have a has many and belongs to relationship. When you change the relationship between these two objects, is that change saved on the parent or is it saved on the child? Now, depending on which backend that you're using, this is like, oh, obviously it's on the child because I'm using Rails and I'm saving relationships as a foreign key. And we're like, oh yeah, obviously. So we hard-coded that semantic in the first version we did. And then we went to like talk to the Mongo guy and we're like, hey, so can you use Ember-data? And he's like, obviously when you change this, it's on the parent. Are you stupid? So we're like, okay, seems bad. So, and now we just ask the adapter. We're like, yo, adapter, what are we dealing with here? And it will say, okay, actually I see this change. I see you've marked both as dirty. So I know for me personally, I only need to save the parent. So you are free to release the child back to being used in the app. It's no longer dirty. The adapter is also responsible for things like what payload is delivered to. The payload is delivered to what backend? What endpoint? So do I hit /posts? Do I hit /crazy Java developer .foo.bar.baz? What do I do? And also things like what actions should I use? Do I use get? Do I use post? Do I use put? Etc. Or even, do I not use the network at all? Do I not use XHRs at all? And do I just write directly to something like IndexedDB or WebSQL? The serializer is responsible for answering questions like, what is the name of the primary key in the JSON payload? If I have attributes, what are their names? So basically in Ember-data, because we're in JavaScript, everything is camel-cased. But many JSON APIs returns fields with underscores. And it feels weird when you're using those JSON APIs in your app, you have camel-cased everything until you get to some random object and it has underscores. And you're like, WTF? So we have a sane mapping between these two. And that's what the serializer does. And so we do things like, how are relationships embedded? Are they embedded as a nested object, or is it referenced by an ID that we will need to load if we don't have it already? So you can think of the adapter as answering the how, and the serializer as answering the what. So the adapter tells how to talk to the server, and the serializer's job is what specifically am I sending, and when I get data back from the server, how am I converting that back into the model that Ember-data expects. So this is where the majority, if you have a crazy API, everything gets isolated here, and the rest of your app can be completely sane. Now, you might be saying, well, Backbone's persistence does the same thing. It has a sync method. And yeah, that's true. You can do whatever you want in Backbone by overriding the sync method. But the problem is if you're not encoding very specific REST semantics, you basically have to start over from scratch. And what we prefer to do in situations like that, instead of just saying, you know what, this is your problem, just override it and do your own thing, we provide hooks that you can override. Now, it's getting late, and I'm on my third beer, so I'm not going to go into all of these exactly. I'm just going to show you, give you a small sampler plate of the different hooks that we provide in all of these, and if you are curious, again, we can talk, or I can point you towards the right documentation. So the adapter, for example, we can say save. Here's a bucket of all the records I'd like you to save. Should commit is a question. This is like the delegate, and you're asking the question, should I commit this particular record? Here's a record that I've updated. Please go save it. Delete record, create record. I'm trying to find a specific record. I'm trying to find many records. Find query, find all. And I think the takeaway here is that we've actually spent a lot of time layering these APIs. So where possible, we have higher level abstractions that use the more primitive things. And basically what this means is you only have to override a few small, simple methods, and everything starts working. And you can go up the stack, optimizing and tweaking to get better performance, or to if you have particularly crazy APIs. And here are some of the hooks in the serializer. So you can convert a record to JSON. You can materialize a record. This is basically like deserializing it, but we got confused. I always get confused between serialize and deserialize, so it's serialize and materialize. You can materialize a particular attribute. You can have, this encodes a lot of naming things, so this is what I was telling you about earlier, in the sense that you have a schema for mapping from underscores to camel cases and vice versa. You have particular keys. There's an API for mapping key names, so you don't have to override these methods. There's transforms to transform date values into JavaScript and all sorts of cool stuff. So the one caveat I will give you to all of this, it's open source, it's been out for a while now. There are apps in production shipping and using it. That being said, the whole thing is alpha, definitely. It's still undergoing a lot of work. Yehuda and I shortly are going to be working on it full time, which I'm really, really excited about. And we would love to get your bug reports. We would love to fix the bugs for you. I don't think there's an option for using a more stable thing, because I don't think anything quite like this exists, but do be aware that if you use it, there will be bugs, and you will have to implement workarounds, and I'm really sorry about that. If you have used Ember-data and you've run into a bug, come see me, I will buy you a beer. Until I run out of Czech currency. So that's it. Thank you guys very much. If you have any questions, I will be happy to take those now. Thanks.
Nějaké otázky? No questions? Yeah.
Okay, thank you for the introduction into that library. And I would like to ask, you showed some magic properties on those models, like is saving, is dirty. And my question is, why I'm getting them with the same API as getting normal my properties I define on those models? What was the reason? Because I'm polluting my namespace. Because what if I want to create my own property?
What's wrong with methods?
No. Yeah, what's wrong with methods? Like, why? Imagine if I want to, for example, create my own property on the model, which is called isDirty. Mm-hmm. For my own use.
Yes, you can't do that. So here's the thing: for Ember-data to work, and to be nice, to have a nice API, in my opinion, we have to be opinionated, and we're not afraid to do that. So the answer is, don't have a property called isLoaded. This is actually not a problem. So this actually is not a problem, because you can easily remap it, right? So I'm sorry if you have a thing called isLoaded, but we reserve that. It's basically like a reserved word in any language. We reserve the word for that. And now, is this a trade-off? Absolutely. And for some people, perhaps you happen to have a set of properties that completely conflict with what we have, and the answer is you would have to remap all of them to something else. And if that's true, I'm sorry. But what's actually, so we made the trade-off that it's just too nice in your templates and in other parts of your code to say record.isLoaded. Mm-hmm. So if we namespaced it or we add additional things, it would affect in my opinion, the usability and the aesthetics. And for us, that's priority number one. We put a very high emphasis on what I'll call developer ergonomics, and we are willing to, I guess, make life a little bit more difficult for maybe 0.5% or 1% of our users if it makes 99% very, very happy and it makes their code more readable to understand. Did you want to throw in anything here?
Just why not methods?
Yeah, methods are not property. And sorry, yeah. So the answer that Yehuda gave is that in Ember, anyway, methods are not properties and properties are observable. So the nice side effect of this is that in your template you can say if if is loaded, do something else. Otherwise, show a spinner or show some special UI. Same for saving. Same for is it dirty, and methods just aren't observable because you don't know when they've been invalidated. For us, we have properties and we know when they're invalidated. So that's the answer for why properties and not methods.
Okay, got it. Thanks.
Cool. Yeah, thank you. I have to say it's real weird talking to someone 5 feet away with a microphone. So thank you. Does anyone else have any additional questions? We have a gentleman in the front. All right, another 2 feet away microphone interaction.
Hey there.
Hello. Hey, how are you?
So, I have a question for you.
Okay, tell me.
I know it's very simple. So, you say that with all the fancy identity mappers and everything, so how do you deal with, do you detect changes on per property level?
Yes.
Or do you just mark the entire object as dirty when something changes?
So both. I'm going to stand here
That's
for a second.
very useful. So,
so we do both. So the
what do
whole.
you send, so the question is there: what do you send to the server? Like only those attributes that changed, or the entire object?
So this is the cool thing about the adapter layer, and in fact the serializer. So this is completely up to you. So by default, so we have built into the framework something we call the REST adapter, and this is the pair of an adapter and serializer that are basically designed to work with the default out-of-the-box Rails semantics. Now, Rails semantics assumes that if you post something that you have given it all of the attributes. But if you are using a server where you actually only want to send the delta, just the changed properties, that's extremely easy to do. Basically, that's a decision that you can tweak like 1 or 2 of the hooks in the serializer, and you can change that. So the answer, so I gave a non-answer, which was both. The real answer is we mark the entire record as dirty, excuse me, but then when we hand it off to the adapter and the serializer and say, hey, go save this to your server, it can say, okay, I know the record's dirty, but what actually changed? And then we can give you very granular information about what other things actually changed.
Great, thanks. And one more follow-up question: how do you deal with like potential like conflicts? So if two clients are changing something,
yes,
and then there is a conflict on the server, is there some mechanics how to resolve that on the client?
So right now, any resolving that you do is manual, and basically the only thing that we do out of the box is put you into an error state, which obviously sucks. And we've thought about this a lot, and we have a plan. We basically have a straw man for some kind of merge API. So in your model, if you're familiar with, for example, like how Git does conflict resolution, you do a 3-way merge, right? So you get the original version, the new version, and then your changes that you've made. And so we'll basically give you all 3, and we'll leave it up to you to do some kind of whatever application-specific merging that you'd like to do, and more than likely include some kind of sane 3-way merge algorithm out of the box, and that will be enough for hopefully many people.
Thanks.
Thank you. Are there any other questions that I can answer? Here we go. We got a contestant. Uh-oh. Oh, my God.
No, don't be scared.
Okay, I'm not.
So first, hi, Tom.
Hey.
Imagine the situation. It's related to the data binding.
Yeah.
You have a table, and the table have 50 rows and 5 columns, and you need to bind every cell of this table.
Okay.
Isn't too much 250 bindings? Because my experience is that render this table takes like I don't know 4 or 5 seconds.
Yeah.
There's
So
a delay.
So let me just say I feel like I'm in a job interview right now. This feels like an interview question. So good question. Put me on the spot. So I have a 2-part answer to that. So the 2-part answer, the first part is by definition, the difference between bindings and not having bindings, of course there are setup and teardown costs, right? Of course there are costs. And right now the setup and teardown costs are pretty fast, but not as fast as we would like. And we have a lot of ideas for making them faster. And in fact, this is one thing that we like about declarative systems is basically we spend a hell of a lot of time optimizing the internals, and basically everyone's app just gets faster for free. And I think that's pretty cool. The second answer to this is the thing that you described specifically is a thing that we are aware of. And we actually have, so we have a guy, Eric Brin, who is awesome. And my employee now, I just realized. Yes, Eric is my employee. We have Eric working on a fix for this, and this is basically called group. So oftentimes you will have many different properties from an object that will all be rendered out, and it doesn't make sense to set up a binding for each of those individual properties, because you know that in your application that those individual properties don't change. The only thing that changes is the entire object. And so it's foolish and wasteful to set up all of these individual bindings. And that sounds like the case that you have.
Yeah.
Yeah. So Yehuda says the expensive part is not setting up each of the individual bindings. It is, in fact, when the whole object changes, you now have 50 or whatever, or 50 times 50 bindings to go set up and re-render.
Specifically, we've actually done recent benchmarking, and the setting up the list is not something
Okay.
we have finally.
Okay. Yehuda wants me to tell you that we have benchmarked this specifically, and it is not the setup and teardown of bindings that is expensive. It is, in fact, the trying to re-render all of these things all at once. So anyway, I've really rambled for a bit now. The long story is we have a new helper coming in handlebars called group. And group basically says all of these things are related. These will all change together. So if one changes, just re-render the whole thing. And that solves many of the performance issues. So talk to me after in like 2 seconds. And we can discuss with you the strategy for you testing this out. It's actually being used in production right now, but it's on a branch. So we will show you how to use that branch, and you can test it out and see if it solves your problem.
Yeah, okay, thank you. Can I have another question related to this?
Yes, please. Yes, go. Boom.
Okay, yeah. So we have a table, and
Tables again.
on the top of this table, I will open the model window. Yeah.
Okay.
I'm using the new route with connect outlets callback.
Okay.
And when I'm closing this window and returning back to the previous route,
Yes.
yeah, this table is re-rendered again.
Yes, because you're basically the modal is opening over
Yeah.
top of the old table. Okay.
Yes. So how to stop this? Because I don't want to re-render this table again. I just want to close this window.
Is it a performance issue re-rendering it?
Yeah.
Okay, so you notice. So it's not just like I would like to do a thing hypothetically, but in fact you notice that it's slow.
Yeah.
Okay. This requires a little bit of nuance and understanding of the Ember view system. So here's basically what we do is we aggressively collect memory in Ember, just because one big problem with many web apps, and in fact many web application frameworks, is they basically just don't care about memory consumption. They just leak and all that stuff. So we take the opposite approach, which is that we try to aggressively manage as much of the memory for you as we can, and that way we can help keep your memory profile relatively flat as your application runs, right? Because these web apps that we're building aren't just running for like 30 seconds and the user moves on anymore. Like you can imagine an app like Gmail or the iCloud apps that I worked on. These things are open for like hours and hours at a time. So memory consumption is actually important. So that's why we're doing it. That's the rationale. And basically, because we keep all the state about your application in the JavaScript space, we know that we can quickly regenerate it in the DOM world if we need to. And that's basically what's going on here. But there are, of course, situations where you have views that don't change very often. You basically have long-lived views that you might swap in and out. There's basically the tab case.
So the modal piece, though.
It's not a modal. He's putting something on top, right? He's putting something on top. And then
Why is it? There's some reason why he's removing the original. Like he's going into a different state.
yes, he's going into a different state. It's replacing. Yeah. So anyway, the answer to this is we want to provide a solution where, so basically right now views, when they're removed, we destroy the element to save memory. You can basically tell it not to destroy the element, but you're basically taking memory management into your own hands right now. And DOM elements tend to be the thing that leaks and tend to be the cause of most of the leaks. So I don't think I can answer this in depth right now just because it requires a little bit, we'll talk, there's nuance. But we definitely want to be able to provide the kind of thing where you have an expensive view and it's long-lived, you shouldn't have to re-render it all the time. So it sounds like we have a lot to talk about, so come find me after the presentation and we'll chat.
Okay, thank you.
Cool. I think that's it. Thank you guys. Is there one other question? Is there someone else? No? Okay. Thank you guys so much for coming out to see me. It's been a pleasure, and I look forward to drinking a lot of beer with you tonight. Thank you.
Chtěl bych všem poděkovat, kdo přišli. Chtěl bych poděkovat taky Good Data za sponsoring téhle akce a za to, že přivezli do Prahy tyhle skvělé přednášející. A taky bych vás chtěl pozvat. Za 14 dní máme náš regulérní meetup zase Prague.js. Téma bude promisy v Google Closure a taky bude tady přednáška o tom, jak dělat pluginy nad browsery pomocí Node.js a nějaký API vrstvy. Bude tady přednáška, co dělají Citasoft, dělají custom extenze nad různýma browserama, mají na to nějaký jednotný API a budou ukazovat, jak to dělají oni. Takže přijďte za 14 dní a nezapomeňte si tady vzít čokoládku od Good Data, podívat se, co dělají. Případně jsou tady tušky, nechceme to nosit zpátky, takže ať to tady není. A teď ještě volná zábava, můžete diskutovat s našimi přednášejícíma a s ostatníma, bar je otevřen, takže můžete pokračovat.